So, good afternoon everyone. This is Purusharth and we are going to start a topic which is ray optics and optical instrument. This is first chapter of part second. So, before starting, I would like to tell you about that what is optics. See, in class 12 we have to study three branches: electromagnetism, optics and modern physics. So, we have selected for today and that is optics. So what is this? This is the branch of physics. So optics is what? Branch of physics which deals with the study of behavior of light. So already we have discussed something about light in class 10th. So let us recap. What is this light? We know that it is a form of energy which gives us sensation of sight, but this is old definition just for understanding that what is actually light. But as we have discussed electromagnetic wave in class 12th only in the last chapter, so I would like to tell you an advanced definition of light. So if you remember, we have discussed about electromagnetic wave. What is electromagnetic wave? If a charge is oscillating somewhere, so because of oscillation of charge, there is a production of time varying electric field which creates time varying magnetic field, and they both regenerate each other. So because of that, a disturbance comes in the space. That disturbance is called as electromagnetic wave. Experimentally, what it was found that speed of the wave, which wave? EM wave, that is produced because of oscillation of charge is 3 into 10 to the power 8 meter per second. So we know that this speed is of light. So we can say that light is a form of EM wave. Light is a form of EM wave, means electromagnetic wave, in which electric field and magnetic field oscillates perpendicular to each other. Oscillates perpendicular to each other. Now, since this is a form of EM wave, so it is having certain speed. So, if we will discuss that part also, the speed is 3 into 10 to the power 8 meter per second. If it is having some speed, it means it is traveling. So the path along which the light travels, that path is straight line. So the path followed is straight line, and we are calling that straight line as a ray of light. So what is ray of light basically? The straight path which the light follows during travel. So when the light is traveling on this path, it is having this much speed in vacuum. Be careful, the speed of light 3 into 10 to the power 8 meter per second is in vacuum. An important note, if someone is asking what is the speed of light in air, we can't say 3 into 10 to the power 8 meter per second. It will be less than 3 into 10 to the power 8 meter per second, because of there is some presence of particles with which the light will strike and will lose its energy. Okay, so we will come to that part. But as I told you that the path followed is called as ray of light. So light is having certain tendency to travel on the straight path. This tendency or this property of light, which property? The property of light to travel on straight line. This property we are calling it as rectilinear propagation of light. Rectilinear propagation of light. So these were the basic things which we already know about light. So what kind of nature we are discussing here is light travels in straight line. That straight line is called as a ray. That's why this chapter is termed as ray optics. Because in this branch of physics, the behavior of light which we are dealing with is that light travels on straight line. So this chapter we are calling it as ray optics. In the next chapter we will study wave optics. There we will get to know that light travels in the form of wave. So we will come to that part, and both things are simultaneously true. Now we will discuss about, see, this was the basic introduction about light. So if I want to tell you in class 10 whatever you radius of curvature. We have discussed mirror formula 1 by v plus 1 by u is equal to 1 by f. These kind of formulas. So in this, like in class 12, what we will do, we will simply derive these kind of expressions. So we have to deal with this part little extra. So if we will come to our first topic, so that topic is relation between radius of curvature and focal length. Very important point. I am teaching and I am expecting that all of you know the law of reflection so that we can deal with this part. So how to derive the relationship? This is the relation f equal to r by 2. Let us say there is a concave mirror. What is concave mirror? Concave mirror in which the outward surface is polished and inner surface is reflecting surface. So the mid part we are going to call it as pole. If a line is passing parallel to principal axis, it will cut the principal axis at a point, and that point after reflection, the reflected ray will cut the principal axis at a point, and that point we are going to call it as focus. This spherical mirror, this concave mirror was made of some sphere. That sphere is having some center, and that center is called the center of curvature. Distance between center of curvature and pole, what we are calling it as radius of curvature. Distance between focus and pole, we are calling it as focal length. So we have to establish a relationship between these two quantities. What? This is r and f. So we are familiar with the part that this light ray when it will incident here. So according to law of reflection, angle of incidence is equal to angle of reflection. If we have to measure the angle of incidence, what we will do? We will draw a normal from this point to the center of curvature. I will explain it later that how to construct normal, but for now itself we can say if we will join the point of incidence to the center of curvature, this line is called as normal. So angle between normal and incident ray is called as angle of incidence. Angle between normal and reflected ray is called as angle of reflection. These both angles will be equal. So if this is theta, so this will also be theta. Why it is like that? According to law of reflection. So this is theta, this is theta. If we will see the geometry, this is parallel line, this dotted line is transversal. So if this is theta, so this will also be theta. Now see again, this line, black one, it is also a kind of transversal. If this is theta, this is theta. So this total angle is how much? 2 theta. So this angle will be also 2 theta. Now a very important point is there. What I have to do, let us consider this point as M, and we are going to draw a perpendicular on the principal axis from this point. If we will draw if we will draw a perpendicular which is falling at point M, now we can do the proof very easily. See, I want to ask you in triangle MCL, if I will ask what is the value of tan theta, so what you will say? Perpendicular by base, so MN by CN. Okay, it is fine. Now in triangle MFN, if I will discuss tan to theta, so what will be that? Again perpendicular by base, so it will be MN by FN. Now an important assumption comes here is, if this is tan theta, this value and this value, we are considering a part for paraxial rays. What is this? For now I will discuss in very short. Paraxial rays, it means for paraxial rays, theta is very small. Theta is very small means angle of incidence is very small. If angle of incidence is very small, so please take care. You are not supposed to keep this figure in your mind, but just for giving you the proof, I am doing this. Let us say this light ray is coming here. So if we will draw a normal like this, so see the angle of incidence is very small, and when we will draw the perpendicular here, so this end point will come very close to P. This is very important assumption. So what we will do is, if theta is very small, so rays are paraxial, it is very good, and if theta is very small, then this end point will come very close to P. So this is very important part for this derivation. So M is very close to P. If M is very close to P, so can I get Fn as Fp and Cn as Cp? Yeah, obviously. So Fn can be written as Fp and Cn can be written as Cp. When? Only when the theta is very small. What is this theta? Theta is angle of incidence. Angle of incidence. Okay. So let us substitute the values. Yeah, one more thing. If theta is very small, we can write tan theta as theta, and we can write tan 2 theta roughly as 2 theta. So what we will do, let us put the value. So theta will be equal to mn by Cn I can write as Cp, and here I will write 2 theta is equal to mn by Fp. Okay, so let us divide the two expressions. So if I will divide, so theta by 2 theta, it will be mn by Cp, and if I will divide, so Fp will go upside and mn will come downside. Mn and mn will cancel, theta cancel, so what we are going to get? 1 by 2 is equal to Fp by Cp. Now tell me, what is Fp? Fp is focal length, is small f, but according to sign convention we will put minus f. And what is Cp? That is radius of curvature, so we will put minus r is equal to 1 by 2, minus cancel, so f we are going to get it as r by 2. So this is the relationship between focal length and radius of curvature, but this is only valid when the rays are paraxial. It means theta is very small. So we will discuss the next topic in the next video. Thank you.